Hello, 7th grade pre-algebra, and today we are looking at lesson 6.4, interior and exterior angles. If you haven't done so already, please have out your packet. We're on page 13. Interior and exterior angles. There is one fact that you really need to know to be able to solve these beyond angle relationships, and that is the fact that the sum of the interior angles of a triangle. And so write this down. I want you to write this on your packet. In a triangle, and you can use a little symbol for triangle. In a triangle, the sum of the interior angles is, do you know what it is? It is 180 degrees. So if you were to add all the interior angles, it doesn't matter what the triangle looks like. You would always get exactly 180 degrees. And we need to use that fact to help us solve our problems on this lesson. So let's get started. Let's look at number 2. Number 2 has x, 36 degrees, and this one. Well, in order to solve for x, we need to know what these two measures are. This one, do you remember what that sign means? Yes, this is 90 degrees. So if we were to add these two together and then subtract that from 180, that would tell us what x is. So 90 plus 36, well, we can do that in our heads as 126. So we're going to take 180 and we're going to subtract 126. And you would get 54. So x is 54 degrees. Pretty simple. I wanted to look at 3 because 3 is, ABC is an isosceles triangle. And these little hash marks here, these little tick marks, they are telling us it's a mathematician's way of saying for this triangle, these two side lengths are equal. And that would make it isosceles. Well, there's another interesting thing about isosceles triangles, and that are these two corner angles right here that come off of the opposite sides of the side lengths that are the same. And that is that these two angles are the same measure. So if this one is x degrees, then this one is x degrees. Now I want to caution you that is only for an isosceles triangle. Actually, it works for an equilateral as well. But if these two side lengths are the same, then these two angles are the same. So then we can set up an equation. We've got x plus 42, and that's going to equal 180. So 2x plus 42 equals 180. Subtract 42 from both sides, and that cancels out. You've got 2x equals 138. And then you divide both sides by 2. That cancels out. X is 68. So x is 68 degrees. There you go. All right, let's look at number 5. Number 5, I wanted to look at that because we are finding what the value of x is. This is 51 degrees, this is unknown, and this is 90 degrees. Okay, I don't expect you to memorize this, but I love angle relationships because they are just chock full of interesting things. Now, if you were to look here at this line segment and this one, that these two angles would equal 180, correct? Now, the interior angles would also equal 180. And since these two angles equal 180, and these three angles equal 180, and they have this angle in common, then x has to be the same thing as these two put together. Say that again. 51 plus 90 plus this is 180. This plus x is 180 as well. Since this is common to both, that means x has to be the sum measure of these two angles. So 51 plus 90 is 141. And again, I don't expect you to memorize that, but I wanted to point that out because I thought that you could understand that. That is kind of a high school level geometry we're working. All right, let's look at number 8. It says find the measure of each numbered angle. AB equals AC equals DC. All right, so here's AB and AC and CD or DC. And these little marks mean they are all the same length. Well, remember what we said. If this is 20 degrees, look at these two are the same length. So this one has to be 20 degrees as well. Okay. And if this is 20 and this is 20, 20 plus 20 is 40. 40 plus this has to be 180 degrees because the interior angles are 180. So 20 plus 20 is 40. 1 has to be 140. And let's see, 140, 160, 180. So that's 140. Well, if this is 140, what does this have to be? As you can see, those are adjacent angles, and they're also supplementary. They make 180 degrees. So this is 140. This has to be 40. Okay. Now, using what we know about isosceles triangles, these two are the same, so these base angles here are the same. So this would have to be 40. So this is 40, this is 40. 40 plus 40 is 80. What do you add to 80 to get 180? Well, it is 100. Okay, so let's see. The measure of each. We got 3, we got 2, we got 1. So angle 1 was 140 degrees. Angle 2, it's right here, that was 40 degrees. And angle 3 was right here, that was 100 degrees. So there's your answer for number 8. Let's turn the page and look at 12. And the directions tell us, focus again. The directions tell us that AB is parallel to CD. So I'm going to go ahead and highlight that. AB, here's AB, and CD are parallel. That's telling me that those angle relationships, when parallel lines are cut by transversal, are coming into account here. All right, we need to find angle 1 and we need to find angle 2. So here's angle 1. Well, I think that these parallel lines are coming into play. And here's our transversal. We are inside the parallel lines. And if this is 22 degrees, this one right here has to be, you know what? Yeah, 22 degrees because these angles are alternate interior. So this is 22 degrees. All right, now that I know that this is 34 and this is 22, I would add those to angle 1 to get 180 degrees. So 22 plus 34 is 56. So we're going to take 180 minus 56. You would borrow, and this would be 124. So angle 1 is 124. Okay, now let's look at angle 2. Well, let's see. 2. Okay, I'm looking at a triangle here, and I can figure out what this angle is. So let's add these two together and subtract from 180 to figure out what this is. And once I know what this is, then angle 2 and this are supplementary. So I can go from there. Okay, so I've got this triangle. 34 plus 22 is, again, 56. 180 minus 56, this is also 124. I just didn't even realize. We've got, yep, 124, 124. Those are Here is the parallel lines. Here's the transversal. These are corresponding. They're in the same relative location on each of the parallel lines. All right, so if this is 124, then angle 2 has to be 56. So angle 1 is 124 degrees. Angle 2 is 56 degrees. There we go. All right, let's see, one more. Let's look at 17. I'm going to come down a little closer. All right, 17. 17, AB is parallel to CD. Whoops, sorry about that. AB and CD are parallel. All right, let's look at this. What do we know? What do we know? I know that these two are vertical. So if this is 36, this is 36 degrees. What else do we know? We know that these equal 180. That's really not helpful right now. I know, okay, I know, all right, here's a parallel line, transversal. This one and this one are inside the parallel lines, opposite sides of the transversal, so they are alternate interior. And alternate interior are congruent. So if this is 2y, this is 2y. All right, now I'm looking here, I see this straight line. So I can add 2y plus 2y plus 36, and that will tell me what, when I add them all together, I would get 180, and I can solve for y. All right, so we've got 2y plus 2y plus 36 equals 180. Combining like terms, 2y plus 2y is 4y plus 36 equals 180. Subtract 36 from both sides. It cancels out, leaving 4y. 4y is 144. Divide both sides by 4. $36. So 144 divided by 4 is 36. So we know that y equals 36. All right. And last one we are doing together is on the next page, number 20. Number 20 says PQ is parallel to RS if M, that means measure of angle 1 equals 60 degrees, and the measure of angle 2 equals 120 degrees. Find the measure of angle 3 and angle 4. All right, so let's look PQ. I'm going to highlight. Maybe I'll use orange. Oh, it shows up. And RS are parallel. All right. Let's see. Measure of angle 1 is 60. So this is 60 degrees. The measure of angle 2 is 120. Here's angle 2 is 120. All right, I am looking right here and I see these supplementary angles. 120 plus something equals 180. Well, what do you add to 120 to get 180? 60. All right, so this is 60 degrees, this is 60 degrees. How many degrees is angle 3? You're right, it is 60 degrees. All right, so we know angle 3 equals 60 degrees. All right, angle 4. I see angle 4 is right here. Okay, we've got two parallel lines. Here's our transversal. Angle 4 is related to this one. Do you remember what the relationship is? Yeah, it is. They are corresponding, and corresponding angles are what? Congruent. So if this is 60 degrees, because this is corresponding, this is also 60 degrees. So angle 4 equals 60 degrees. All right, class. So we have been using angle relationships to solve problems. It is under the umbrella of geometry in mathematics, and we are getting close to the end. I think this may be our last lesson. Have a great day, and I will talk to you soon. Bye.